Welcome, everyone. Today we're doing a deep dive into something that honestly sounds like science fiction, but it's very real.
It really does push the boundaries.
Right. Our mission is to unpack the world's first successful pig-to-human kidney transplant. We've looked at the sources, and we're ready to explore the details.
Let's get into it.
Okay, so let's paint the picture. Massachusetts General Hospital, March 2024. You have a 62-year-old man, end-stage kidney disease. He receives a pig kidney.
A genetically modified pig kidney, which is key.
Exactly. And the really groundbreaking parts, the kidney started working, like, right away. No immediate rejection.
Which is huge. Usually that hyperacute rejection is the first major hurdle.
So why even attempt this? What's the context here?
Well, it boils down to a crisis, really, the organ shortage. In the U.S., over 100,000 people are waiting for a kidney.
100,000? That's staggering.
It is. And tragically, many people die waiting. So the need for an alternative source is incredibly urgent.
And pigs. Why pigs? Seems an unusual choice at first glance.
Not as unusual as you might think. Our sources point out that pig organs are actually surprisingly similar to ours.
Similar how? Size? Function?
Both, actually. Similar size, similar basic function. That makes them a good starting point, biologically speaking.
Okay, but it's not just any pig kidney, as you said. There's some serious science involved here.
Oh, absolutely. This is where it gets fascinating. A biotech company, eGenesis, used CRISPR gene editing.
CRISPR, we hear that term a lot. It's like super precise genetic scissors. Right?
That's a great way to put it. They used it to edit the pig's DNA. Specifically, they had to remove certain pig genes.
Why remove them?
Because those genes produce antigens, markers on the cells, that the human immune system immediately recognizes as foreign and attacks very aggressively.
So taking those out helps prevent that initial rejection.
Precisely, but they didn't stop there. They also added some human genes.
Added human genes into the pig kidney.
Yes, specific human immune regulatory genes. The idea is to make the kidney look, well, less foreign to the human body, to help it sort of blend in, immunologically speaking.
Okay, wow. Anything else?
One more crucial step. They deactivated certain pig viruses. PERBs are called porcine endogenous retroviruses.
Viruses in the pig's DNA.
Exactly. There's always been a concern they could potentially, jump to the human recipient, so they switched those off too.
So removing bad stuff, adding good stuff, disabling potential risks, that sounds incredibly complex. Making sure all those edits worked correctly must have been tough.
Extremely challenging. The precision needed, ensuring stability, it's cutting-edge work. But the proof is in the pudding, as they say.
Eating the fact that it worked.
Yes, the fact that the kidney functioned for several weeks without that hyperacute rejection shows they really nailed those complex genetic modifications.
And it functioned immediately, like making urine right after surgery.
Sources confirm exactly that. It started filtering blood, producing urine, basically doing its job straight away. And the patient was stable for weeks.
That's just mind-blowing. What does this one success mean for the bigger picture? Is this the future?
It certainly feels like the dawn of a new era. Xenotransplants, these animal-to-human transplants, could potentially become, well, almost routine someday.
But we're not quite there yet, I assume.
No, definitely not. This is a major first step, but crucial next steps are needed. We're talking rigorous regulatory approval, FDA processes, and much longer-term safety studies.
Right. We need to know if it's safe and effective, not just for weeks, but for years.
Exactly. But if, and it's still an if, but a promising one, if this can be scaled up safely.
The impact could be enormous, saving potentially hundreds of thousands of lives every year.
That's the potential, yes. It could fundamentally change how we treat organ failure worldwide.
It really shifts the paradigm.
It does. And, the doctors involved said something powerful. They said, this is not science fiction. It's the future of transplantation, and the future is now.
That quote really hit home. It's not just a new treatment, it feels like. Something more profound.
It signals a shift towards maybe biological reengineering on a scale we haven't seen, moving beyond just treating diseases to fundamentally altering biological capabilities.
So a final thought for you, our listener.
Yeah.
What does this incredible leap really signify? Think about how it might change our understanding of health, of life itself, and just the sheer speed at which biology is innovating. Where does this path lead?